cross-section of data science and data engineering. I will try to bring in certain aspects of data science and how you can use it in the databases. So little bit about myself. I work as a chief data officer at Bizom, and I started as a software engineer and then transformed into a data scientist and so on. I generally work on the data, retail data, and we publish a lot of these reports which get published in Economic Times and other places. So if you just search Bizom and Economic Times, you will find a lot of articles saying what is happening in India. So that all comes from our team. So the talk is like who we are, basically a little bit about Bizom and what we do. Then I will give some overview of the concepts that are required to build this kind of like intelligent search systems. Some patterns and then case studies, certain works that we have already done in our organization. So Bizom, if I have to keep it very simple, it is a Salesforce automation software. It helps in the merchandisers or the distributors to keep their products in the Kirana stores. So this is a Kirana store that looks like every corner of the street you have this kind of stores. How do we get these inventory in this store is the thing. And what happens generally is a salesman goes to the shop, he asks what you want, he writes in a paper, then sends it to the distributor. The truck comes next day or maybe 3-4 days later, and the product is delivered. What we do is that we create an app, or we provide an app to the salesman. So this entire paper, bookkeeping kind of a stuff is gone. So as soon as the order is punched in the app, the distributor is notified that you have to give this much of inventory. So this entire cycle, which takes around 7 days, is cut short to like 3 days or 4 days. In this entire process, a lot of data is generated, like what products were bought, what price range, which particular geography these products were sold. So that is where the entire retail analytics comes into picture. So now about the talk. So you might have seen this particular ad these days, Samsung Galaxy Google One. Have you ever wondered how it is going to happen? Like, is it a magic that is going to happen? Similar thing happens in Google search these days. It's an image search, and then in the image itself you can pinpoint a particular section, and then the search comes regarding to that section. This is what is happening these days. Google and Samsung are promoting a lot. But I will show you at the end of the talk that you can develop the system yourself. Not at a Google scale, but quite a bit. I know this is a data engineering conference, but I will also have to cover a little bit of concepts just for you guys to appreciate. So basically, if I have to put it very simple, any search that you have to do has to undergo certain process. The text that you write cannot be just submitted in the same way. It is converted into something called as embeddings. So what is embedding? This entire text is broken down into words, and then these words are given some IDs, and these IDs are converted into more vector form or more numerical numbers, which is we call it as embeddings. So simple example, I mean, you would have seen this. There are 4 words. Every word has been given certain number, score, based on certain features. So a dog is an animal, it's a canine also, pet also, it moves, color is there. Basis of this, some numbers are given. And then similarly, every word has been given certain numbers. But if you look at it, there is a certain kind of a relationship between these, the way the numbers have been given. If I plot this thing into a 2-dimensional graph, I will see that the words which are close by comes very close in the graph. And that's the whole trick. The similarity or the way the searches work is exactly like this. Which thing is nearby what? So I'll skip certain slides because I think they will be too much. And the key concept is the similarity score. The way the similarity score comes is the angle between the two vectors. It's a basic maths. People try to make it a very big complicated formula, but it's basically finding the angle between the two vectors. Depending on how or what algorithm we have used, these embeddings can be very, very big or they can be very dense. The denser the embedding, more is the semantic or the contextual information available. The lesser the sparse the embedding, less is the information that is available to us. So ideally we should be looking for the dense embeddings to create something like what I showed in the first slide. Coming to the vector databases, so first part is the embedding which you need to get this search work. The second is the similarity score that we saw that cosine similarity is good enough for that. The third is the databases where you want to save your entire embeddings so as to do the similarity matches and all. This is where the vector databases come into picture. The difference between vector database and a normal database is if I have to save it in a MySQL or some kind of an RDBMS, this entire big vector will be saved as a blob. And you can't do much on it because it is opaque object. You can't basically figure out which two objects are matching each other. I mean, the blob has that kind of a problem. So there is a special database called vector databases where they can save this entire thing as a actual type, data type, and then they can do a similarity matching at a very high speed. One more thing is that we are not looking for an exact match. It's not that if I say dog, you have to give me only the dog images, you can give me puppy images or anything related to that. That's the key, because when we become very, very exact, the results will be less, and this is not what we are looking for. If you look at the first image, there are so many turbans photos that have come. None of them are exact match, because this is similar match. This is not an exact match. That is what we are looking for. That is the thing. Just to give a historical setting of how the searches generally are created. One is a keyword search, where you say I type milk, I get all the milk products. Now the problem in today's scenario is that suppose I am talking from a retail point of view. Say you type milk, it will give you milk chocolate also and a milk product also. But this is milk chocolate may be a noise for me because I am not looking for a milk chocolate. So keyword search basically doesn't work in intelligent systems because a lot of garbage results come out. But it is very easy to create. Basically you just have to save all the words and you just have to match these words. You can improve that keyword search with an inverted search where the kind of storage is not. So the difference between the two is, here we are saying the entire document has these many words and then you are matching the query words. In the other case, the word is associated with the document. So we are saying that this is a word and this is present in so many documents. So now you are matching only the words and not the documents there. So this is little fast, but still the output will be almost the same, wherein you will get a lot of spurious results. Now coming to the semantic part, just try Google. First you do a login and then you search something and then you log out, log in with some other credential or don't log in, you will see different results. That is what is the contextual or a semantic search. Same thing happens, like sometimes you by mistake or purposefully put some common names. Like I am searching for a flight to Silicon Valley. Now there is no place called Silicon Valley, but we know what all nearest places are associated with Silicon Valley. And the system can figure out that it is San Jose in US. So this is again a contextual information that has been built up. So just to summarize, three things: embeddings, storage strategy and search algorithms are the three things which are powering all of these stuff. I just want to talk about one more thing. So when you are storing the vectors, it is also very important that these vectors are similar vectors are put together and distant vectors are put as far as possible. because what will happen is that, as we are saying, it is a similar kind of an output. Lot of other results will also start coming if you have not put these vectors apart. So if you look at it, if I put the vectors like this in the vector space, everything is like a spaghetti. Everything is mixed up. The results will be totally wrong because anything can come. So we have to put them apart. So the blue color vectors should be apart from the red color vectors and so on. So there are certain ways in which you can do it. Sentence transformer is one of the easy way of doing it. Now coming to one of the very important thing, and which will actually is important to understand the use case. Today you can actually, if you guys use ChatGPT or other such kind of tools, you can give an image and you can ask a question in natural language, right? Now how does it happen? It happens in a way, see, everything can be converted into a vector or the embeddings. So image can also be converted into a one-dimensional vector, voice can also be converted, a text can also be converted. But all the three things are converted by different algorithms, because the way the things work are different. One is 2D, one is 1D, and so on. Now to make them work together, you need to bring them to a common denominator. It's like I ask a question in English, and if you don't understand English, you will not be able to answer it. Whether you, you may know a lot of other languages, but you need to understand English also to answer it. So same thing I am doing here. I convert the text into a text embedding, I convert an image into an image embedding, and then we do a fusion. We say, let's bring them together in a different embedding model, and this is where we will be querying. So Flip is one such algorithm, and it's a very useful one. So just to give you a sense of what I just told you previously, today you can give an image and ask for images. So you give a photo of a shoe and similar kind of shoes can come. You can also write a query saying red striped shirts, and then it will search you in the images and give it to you. This is a textual input and a output is in the image. The simple text to text is any website, like a travel website I showed earlier. And image to text would be caption generation. You give a photo of a running dog and a caption comes. It's a photo of a running dog. So all the four combinations and permutations are possible just by making them together. Diagrammatically, if you see, first one is the image signal, the bottom one is the text, and we have plugged them together to make a common signal. Yeah, so let's talk about the example only. The fashion is a very common use case. We all do shopping, and now how many times do we want to ask for a particular pattern? Like I want to search for a shirt which has certain specific cartoon or certain specific monogram or something like that. I don't find out a website or maybe even the top sites don't give me that kind of a liberty to actually search for the exact thing. I can search for a red color shirt, but if I want a red color shirt or a green color collar, it is very difficult to get. You will get a green color shirt also and a red color shirt also. This is an example photo I took 2 days back from a popular site. I am searching for a flower logo t-shirt. Look at the top results that have come. There is no result which has a flower logo. Okay. And this is a very annoying thing. With the technology that I have discussed till now, this is what I want, and I can create this. Basically, when I say flower logo t-shirt, all I am saying is that you convert this text into a embedding. You find out those images where either flower is present or basically flower logo t-shirt. So images which have that kind of a thing. So basically the bottom images, all of these embeddings will be matched with the flower logo t-shirt caption, and they should be written. This is what is the need. And this is what experiment we did a few months back. None of these photos have actual description saying that these are cartoon logos in the first place. This one. But if I search t-shirt with cartoon logo, all of these come and everybody has a cartoon logo. The other one is a green and white shoe for running. Again, none of these photos, meta information or a product description says that they are running shoes or they have a white or green color thing. But this is coming. The last one is a very two things are happening here. One is a color combination is happening. All the kurtas that are listed down are all dark color kurtas. All the light colors are this side. These are also have a floral pattern. There is, I don't know any search which gives you this. I actually tried few days back search on one of the top fashion site. You can guess. Their result was we don't find anything. And I wrote a very good LinkedIn post also about it. But this technology can help them if they want to. Now this is something coming from our database. So we said, why don't we use this technology to figure out one of the burning problem, which is outlet discovery. I am a brand, I am say Britannia, and I want to sell my biscuits in certain geography, and I am looking for a specific kind of an outlet. How do I find out? There are millions of outlets. To be precise, there are around 20 million outlets in India. So what we did was that we took these images, again created vectors, and we just said these are like coming from actual data, outlets selling vegetables. All these outlets are vegetables in the front. And I had no idea that these outlets exist in the system. Outlets with Coca-Cola logo. So if you are looking for an outlet where I can put a fridge, or I already have a fridge but I can put my own beverages, this is a very good output. In fact, we are working with some of the guys to do this work. And this is all coming from Clip. So whatever technology I have discussed till now, sufficient to power this up. This is another example where the generative AI comes into picture. So a lot of times it happens that I really want to have product descriptions. So I am okay with this search, whatever I showed, but for the completeness sake, I want to show a description also. But descriptions are generally not there. I mean, you ask for, like we work very closely with a lot of brands, and if we ask them, give me a proper data, all they will give us these pictures. And they will say, go figure out. So what we said, okay, let's generate some text. So we used one of the algorithms to generate text. And this is what we got. The product in the image is a pack of crazy pops. I assume that this entire thing, what has been generated, is say 70 to 80% correct. So, but there are enough keywords for me to create a meta information around it, which is good enough for me. And then I can query basis of the picture as well as basis of the text. So I said fruit flavored lollipops. So if I just search on the images, I get these two answers. And if I search on the text which has been generated, I get this answer. And I club them together and I put a re-ranking saying that which was common in both the outputs to get the final thing. And the result will change if I do swirl lollipops or mango lollipops and all those kind of things. So this is a very common way of doing it, and everything has three parts: embeddings, similarity search based on cosine, and third is a vector DB. Your vector DB can be Pinecone, which is a commercial solution. Even all the vector DB that I will be telling the names are commercial, but they are like towards the expensive side. Then there is a Postgres SQL. Not many people know that Postgres is a good vector DB. There is a code called PG vector, which is used to create the vector indexes. And this one is basically using that particular technology. And the last example is very common to, is very overlapping with what there was one speaker, I think Padma, who talked about hotel search, image based. So she was talking about some algorithms. I don't want to comment on those algorithms, but whatever my knowledge is, these algorithms are very sensitive to the way the image is taken. If you suppose take my photo in a different orientation, those algorithms will fail. But in our use case, what happens is, so I'll tell you why this use case makes sense for us. There's something called as an auditing of an outlet. So a salesman is required to take a photo of the outlet to which he is visiting. And that is required for auditing purpose, meaning they want to make sure that this is the right outlet and all these things. But the salesman has also dumped lot of wrong outlets or fictitious outlets in the database. Because his one of the KPI is that whenever you go on the beat, or which is called visits, you also have to add new outlets or new kirana stores so that the business can grow. But there are limited number of kirana stores in one locality. I mean, I've been living in this area for now very long time. I have not seen many shops coming up. But this salesman will somehow find every month a new shop. The reason is that he is just changing the name and then putting it. Now the requirement comes that you have to put a photo also. So what he will do, he will take a different angle photo. And if you are looking at from visual eyes or maybe just a regular picture-to-picture comparison, these will pass. Look at these images at the bottom. The first image shows a woman standing on the counter. The other image shows two boys and one bike. I don't see any regular image comparison will catch this thing, because these are the two exactly same shops. The names are same. Okay. Just by doing an embedding match, a vector match, you can find this. The other example is very humorous. The person has taken the top view of the outlet, and then he has taken the bottom view of the outlet. And still we can find out because of this bald head over here, and there are certain toothbrushes which are there. So think about it, there are millions of images which we have to figure out. This use case nobody can find out manually. With tools also it is very difficult. With this particular, like what we have used, images converted to embeddings, then did a similarity match with a cosine similarity, and just giving out the output. From a efficiency point of view, 10,000 images can be processed in 2 minutes. So that's the scale at which it works. So if you now look at that first figure that I was showing, what do you think will be the technology that is used? What is the technology do you think will power this solution? See, basically you are doing a crop of an image on the top, convert into a vector. You have a database, I mean Google has a database of all the turbans or all of them, and it is just trying finding out what is there. It doesn't know that you have cut a turban. So that is the difference between a typical object detection versus this one. In object detection, you know for sure what all objects you want to search for. I know that I want to search for a remote, or I want to search for a human. In this you don't know. The person can create this crop on anything. So the only way is that dynamically create a vector, figure out in all your vectors which vectors are close by. And this is exactly saying what Samsung is doing and charging you extra money. I mean you can do yourself. I'm done with my set of slides. I will